We're going to evaluate the indefinite integral of square root 30x minus x squared. Uh, this integral problem is a bit harder than your regular integral because you can't just use u sub for this problem, and you'll find that you'll have an extra x when you differentiate u. So when you run into a problem like this and you have this polynomial under square root, you're going to have to use something called completing the square. We're going to have to use that technique in order to simplify this integral into something that's easier to integrate. And so the first step is to integrate this inside function, this inside polynomial, which is this 30x minus x squared. And so we'll do that right now. And the formula for completing the square is if we have x squared plus bx plus c, to complete the square, we'll have x plus b over 2 squared plus c minus b over 2 squared. There. And so for this problem, when we're trying to complete the square with this inside part, I'm going to take out the negative, and we'll have x. And since it's negative 30 now, since I took out the negative, we'll have minus 15 squared. Because 30 divided by 2 is 15, plus, we don't have a c, but we still have the b over 2 squared. There. And so this whole thing is equivalent to this whole thing. And then we can basically rewrite this whole integral as the integral of, it's still in the square root of, and I'm going to distribute this negative back in. In this case, the negative on the outside and this negative here cancels out, makes a positive, but there's going to be a negative here. So we're going to have this as negative x minus 15 squared plus 15 squared. Now, the cool thing here is that the integral of this thing is exact same as this thing, because all we've done is rewritten this inside polynomial. Now what do we do? This doesn't look too much more simple, but the reason why we do it this way is because there's going to be a trick we can use. If we wrote this inside x minus 15 as a variable called u, for example, we can use this little trick called trig sub integration, where we follow these rules, and it's if it's a squared plus u squared, we can sub in u as equal to a tan theta. Or if it's a squared minus u squared, we can sub in u as equal to a sine theta. And then if it's u squared minus a squared, now u can equal to a secant theta. And where these come from is from, for example, if let's use sine, for example. We know that sine squared theta plus cosine squared theta is equal to 1, right? And so therefore, 1 minus sine squared theta, in this case, u squared, and 1 squared is just 1, is equal to cosine squared theta. So that's why we kind of sub in u as sine squared. And so for our example, we can sub in x minus 15, and since this portion is basically the u, but it's negative u because of this guy, if we remember from that list we had, we would have u as sine. And so x minus 15 will equal to sine theta. And what's a? Well, a is just 15 because it's a squared. In this case, a is 15. And so we'll rewrite x minus 15 as equal to a, which is 15 sine theta. And then we can also rewrite dx, because we're putting things in terms of theta now, as equal to the derivative of 15 sine theta, which is 15 cosine theta, and now it's d theta. And now we can make these substitutions in, and we'll have the integral of negative 15 plus 15 squared times, because dx is now written as this, we have to have this on the outside. 15 cosine theta d theta. So now we have this. Now again, this doesn't look too much more simple, but we remember that trig identity that we had before. Sine squared theta plus cosine squared theta is equal to 1. In this case, if we distribute the square in, we'll have, and let's reorganize this. We'll rewrite this as the integral of 15 squared minus 15 squared again, and now it's sine squared theta. And this will just come down, and I'm going to take out the 15 squared. 1 minus sine squared theta. And then we can also write this finally as the final thing would be taking the 15 out, because the square and the square root cancels out. And then inside the function, we have 1 minus sine squared theta times 15 cosine theta d theta. And then from here, if we move the sign to the other side, we have cosine squared. So therefore, we can write this as cosine squared theta. We're left with the integral of 15 square root cosine squared theta times 15 cosine squared theta, cosine theta d theta. Squaring the square root cancels out. And again, simplified again, we have 15 cosine theta times 15 cosine theta d theta. We're going to take the 15 squared out from the two 15s. And now we just have the integral of cosine squared theta d theta. Cosine squared theta is, again, simpler, but not entirely easy. We have to use, again, another trig identity, and that is cosine squared theta is equal to 1 plus cosine 2 theta over 2. And why we do this is because we want to get rid of that square. That's a bit annoying. We can rewrite this as 15 squared and the integral of, I'm going to just write like this, 1/2 plus cosine 2 theta divided by 2. And then I guess this is then d theta. And then if we actually integrate 1/2, we'll have 15 squared. I'm going to finally start doing the integration. We'll have 1/2 theta. And then the integral of the cosine 2 theta over 2. Sine 2 theta over 4. And yeah, so this is the final answer, but not the answer to the question, because the question is in terms of x. And so To put everything back in terms of x, we have to remember the sub we made. And so we have this answer, but recall that we did the sub, that 15 minus x minus 15 is 15 sine theta. Now we have to move this theta back in terms of x. And so that's not too complicated. If we separate this, we have x minus 15 divided by 15 is equal to sine theta. And then theta specifically is just arcsine x minus 15 over 15. And so the final answer is 15 squared arcsine x minus 15 over 15. This all over 2 plus sine 2 arcsine x minus 15 divided by 4. And the most important part is plus c, because it's an indefinite integral.